In our next session, we will take a look at SSL policy, which has two main applications on FTD. We can use this policy to perform decryption of encrypted web communications, so to transform HTTPS into HTTP. And second application is to allow you to selectively block encrypted communication in general. Because I believe that in 6.2, it is not only possible to block encrypted web based on certain application layer information, but you can also block other SSL protected sessions, like for example SNTPS or IMAP-S. Notice that when you enable the SSL policy, it is gonna change the handling of the encrypted communication inside of the ACP, because we know that we can use regular access control policy roles to, let's say, choose HTTPS, or maybe go for layer 4 information like block packets going over port 443. With SSL, it is going to change. SSL policy is always going to take precedence for encrypted communication. And the FTD is going to be able to tell what traffic is encrypted and what is not, based on the application detection. All right, now let's talk a little bit about internals of the decryption process. There are actually two ways how FTD performs the web decryption. One is to use the so-called decrypt known key action, which is generally intended for communication destined to your network, to your servers. Like when someone is connecting to your public address on the DMZ, and this is a web server, you support SSL TLS or just HTTPS in general, and you want to see what the client is sending to you. Now, for this to work, you will have to upload the server's private key. Specifically, it is going to be the entire certificate of that server to the FTD. So if you plan to do the decryption on the traffic sent to 3 different servers, you'll have to upload 3 different certificates, each belonging to the respective server. And this is going to be needed so that FTD knows about the private key of a given server. So it can then use this key to decrypt the client-server handshake that is going to take place normally between the original client and real server in order to establish set of session keys. So this is normally going to be at some point encrypted. But since we will know the right private key, we will be able to decrypt the content on the fly. Even that technically FTD doesn't have to be physically in line with the data flow. Okay, and this is as opposed to the decrypt resign action, which is normally used to do the decryption on the communication going in the outbound direction, like from your internal network to the external servers connected to the internet or maybe a partner's network. And what is going to change in this case is that FTD is not going to have private key that belongs to those external devices, because those devices are, of course, under someone else's administration, under someone else's control. So we will not be able to get private keys bound to those servers, which means that FTD will have to somehow mimic the real server to the client, and it will have to mimic the client to the real server. So in this case, FTD is going to actually act as a man in the middle. It is going to act more of like a proxy, because the goal now is going to be to fool the client into believing that it's now FTD what's the real server, and FTD is also going to try to fool the server that it is actually acting as a client for the session. So from the SSL control plane perspective, in this case, there are going to be 2 sessions. We will have the server. There is going to be that FTD, and in this case, FTD is supposed to sit in line with the traffic because it will be modifying some of the packets. and we will have our original client. So normally we know that it's going to be the client what negotiates that handshake with the server. But in this case, things will change. The client will want to connect to the server, and FTD is going to intercept that packet and send it to the server, appearing to act as the client. So this is the server, this is the client. And this is going to make the first half of the session. And then as the server replies, so this is the client, the FTD is going to appear to be a server to the real client. So we will have two separate handshakes. Handshake number 2 between FTD and the client, and handshake number 1 between FTD and the real server. So technically speaking, there are going to be two separate sets of keys, and there are going to be actually two certificates involved in this exchange. One certificate is going to belong to the server, and the other certificate is going to belong to the FTD, and this is what is going to be then presented to the client. Now this certificate will technically mimic the server certificate, but some information inside of this certificate will have to be changed, and of course it's going to be the private key of the FTD what is being used for this certificate. Okay, one important thing to remember about is that once the decryption took place, no matter what method was used, known key or resign, the decrypted communication, decrypted packets will be still subject to the inspection by the access control policy. Because this is actually the goal of decryption. We want to see what's inside of the packet, so we can then evaluate this content against our regular access control policy rules. Okay, now decryption is not the only action that you may select in the SSL policy. There are a few other actions. You may simply pass the flow unencrypted. You may block the communication in an encrypted form, which is going to be generally used to reduce the load on the decryption engine. So it's not going to be the goal in most cases to perform decryption on all traffic, like all outbound connections. You could do something like this. Well, you might do something like this for, let's say, web communication, but you will still add some exceptions. And for some traffic, you will want to explicitly say that you don't really want to decrypt it. So maybe there are servers that you know it doesn't make any sense to do the decryption for, because you already know that they contain malware. In this case, you can simply block encrypted communication without doing the decryption. So SSL policy itself is also capable of blocking packets. And there are going to be actually a couple different ways how you can select the traffic you want to block without decrypting it, because we know that we cannot actually act on the content of the packet. But as we will see in just a minute, there are actually two methods that FTD uses to figure out where's the encrypted traffic destined to. In general, you will be able to match a lot of fields from the server's certificate. So when FTD sees the server certificate, you will be able to build your policy based on elements such as distinguished name, like SSL TLS version used in the negotiation, and maybe the cipher suites, or even URL information. This stuff is going to be generally included in the certificate that belongs to the server, or in case of the URI, and this is going to be extracted from the so-called server name indication SNI, which is just a special field available inside of the TLS client hello message. This is an optional information, but many browsers use SNIs, and when they do this, they simply set the information about the website the session is going to be destined to. Because remember that with encrypted HTTP, the URI information doesn't go in clear. It's also encrypted. So FTD is going to be able to catch the SNI inside of the TLS client hello message, and this is how you will get the URI. Versus this first method, the certificate It is going to allow you to figure out stuff such as certificate status, like distinguished name, and also some other information. Now, one problem that you can actually run into with servers, a certificate, is that in some cases, the certificate was defined for more than one system, which is known as a wildcard certificate. Like, for example, if we were to take a look at Google's certificate information, let me take a look at this certificate and take a look at this issued to. It is issued to anything at google.com. We take a look at the details. This is the subject. I want to take a look at the somewhere here it is going to list those different the ends. So it's going to be the subject alternative name field, what lists individual domains when a subject was set to be a wildcard. So we see that Google uses a single certificate for multiple websites, like Google.com, Android.com, and then also YouTube sites, and some other URLs as well. So of course, a certificate like that would not give you an indication about the URI, but assuming that the browser supports SNI and uses it, you will get the URI from this portion of the packet. Okay, as I said, decrypt is not the only action that you can do. With your SSL policy, you can monitor, which is to log the session, but still check other rules, like with any monitor action on the FTD. You can block and optionally also send a reset. So this is what we will use to block encrypted traffic without decrypting it. We can, of course, do the decryption with known key or with the resign method. And finally, we can not do decryption. We can simply pass the traffic encrypted. And this is going to be treated as a final action, so we will not be evaluating any other rules. Moving on, we will now talk about configuration of our SSL policy. And we should start with defining an object, a PKI object, which is going to be needed to import the right certificate. So we can either perform the decryption on the outgoing traffic or maybe on the inbound communication to one of our servers. So we will have to go to Objects, Object Management, and select the PKI type. And now if you plan to perform decryption with the resign action on the outgoing communication to external servers, you will have to upload a certificate for the ACA certificate to the internal CA store. Versus if you want to do the decryption on the incoming SSL communication to one of your web servers, you will have to add an identity certificate to the internal certificate store. So you'll have to download the certificate from the server and upload it over here. And maybe let's quickly take a look at this. I'm gonna add a certificate to the internal CA store. We will just go to Objects, then down to PKI. Because what I will be showing you in this session is gonna be encryption on the outgoing communication. So in this case, it's gonna be FTD what is gonna act as a man in the middle. Okay, and the simplest method, the simplest solution, let me find the PKI objects, is going to be to generate a self-signed certificate. But before we do this, let me quickly recap on those different four types of certificate stores. We've got the internal trusted, external, and internal. So whenever it says CA, it means that it is talking about CA certificates. Now, whenever it says certs, it means that it is talking about identity certificates. So certificates for our end hosts. And this internal CA, this is obviously going to be for our internal certificate authority, the one that we manage. Now the trusted CAs, this store is used for public CAs, those that we don't manage. And then external certificates, this is for certificates that belong to the end system outside of our organization, versus this is for certificates for the end systems that belong to our organization. So in this case, we're going to be dealing with the internal CA, since we want to upload or just generate, in this case, a certificate that will belong to our certificate authority. I'm going to say generate CA. I will call it FTD certificate, or just FTD cert. It is going to be for US, San Francisco, and here I'm going to say Novodyne, and OU I'm going to set it to be security, and common name I'm going to set it to be ftd.ndtrainings.com. Now let's generate it. And this is something that we will then select in our policy. Okay, so how do we build a policy? We will have to go to the policies access control SSL and add the policy, and then also add individual rules. So maybe let's go ahead and do this, or just take a look at this first. Let me choose policies access control SSL, because there is something I want to show you before we will actually add a rule. I'm going to call it my SSL POL. The default action is going to be set to don't decrypt. Okay, and when I edit this policy, and this is where I can specify what to do with the traffic that is undecryptable, like if the session is compressed, or maybe FTD does not support a certificate. So by default, it is going to inherit the default action, which is to not decrypt, but I can choose block or block with reset, or just explicitly tell it to don't do the decryption. And then we've got those rules, 3 separate sections. This one is for more of like the exceptions, where by default, when I click on add rule, it is going to be adding them to the standard rules section. You can customize this stuff. You can add your own categories. So here is when you can choose the conditions as to what traffic to inspect with the policy, like for individual users, maybe groups of users, traffic flowing over certain ports. This is where you can choose applications. You've got almost 400 applications that you can, for example, say you want to block instead of decrypting them to save the resources. So this stuff is for applications. Then we've got URL categories. Like when you want to filter based on the URL, it is going to take from the certificate, server certificate, or based on SNI. We can filter based on the certificates or fields distinguished name from the certificate, or maybe based on the certificate status. Like I want to block connections to servers with revoked certificates, or maybe simply invalid. And I can also select Cipher Suite and the version, like for example, block SSL 3.0 connections. Okay, so once we have the policy and the rules, we will have to activate the policy, and this is something that we will do in the ACP. Okay, what we will do in our case is that we will test the decryption from the PC located on the inside, and we're going to use router 4 as a web server. So this is my inside, this is my outside. And the rule is going to be pretty straightforward. I will just say that we are looking at all inside to outside TCP 443 traffic. Let's also say we want to log. And the role name is going to be set to outbound SSL. Out SSL. Okay, so this is something that I'm going to save. It went to the standard section. And then you will have to go to the... Oh, no, hold on a second. I don't want to block. I want to decrypt with resigning using our custom certificate, like that. Okay, so save once again. And let me also disable the certificate status. I saved the previous options. So I just want to look at the TCP 443. Now this is what I want to decrypt with signing. Okay, once again, save. Then go to the access control policy. And activate our SSL policy with this option. So by default, it doesn't use SSL policy. We'll click over here. It is going to move us to the advanced tab of that ACP. I'm going to select my SSL POL. We're going to save and push this change. And you know what? Maybe before we actually push, let's try to first connect to the web server 172.140.1.4, and let's see what is going to be the certificate that we will get from this device. Let me take a look at the certificate fields. It says that it is issued by iOS for iOS. So this is a self-signed certificate that was generated by router 4. And the reason that I wanted to show you this is that once we finally push the change, FTD is going to act as a man in the middle. So it is going to act as a server to the client, to the PC, and it is going to act as a client to the server. So as I explained earlier, there are going to be actually two sessions, 2 and 1. FTD is going to accept certificate coming from router 4, and PC is going to accept certificate coming from the FTD. Let me go back to the FMC. Let's see if it is still deploying. So we need to still wait until it finishes the push. Okay, now we see that the configuration was delivered. So we will go back to the client. And let's give it one more shot. Let's say HTTPS 2.4. Okay, I'm gonna say add exception, and we will actually get the certificate and maybe take a look at it. So notice what's different now. The command name is still router 4 because the certificate is for router 4 for our server. But the issuer is now our FTD. This is the self-signed certificate that we generated on the FTD. Okay, I'm gonna confirm this information and we can still log in. Now if we go back to the access control policy, because this is something that I didn't actually show you, we have a role from the previous session that allows all inbound to outbound communication. So once the decryption took place, we're gonna hit the second role, inside to outside, which is to allow. So what we should see in the logs is that we're gonna have 2 connections, actually even more, because I enabled logging in this rule at the beginning and at the end of the session. But you will see that there is the decryption which is going on. and then the traffic hits the policy. So here it says it was HTTPS initially, and then it says this is HTTP, and it is now able to recognize the browser and tell us the exact URL. Because what it shows here is just a certificate. It's apparently the certificate of the server, like its name. And we can also take a look at table view of connection events. It should mention that there was a decryption that was going on when we take a look at those details. So we see that it was actually doing the decryption with the resign action. And then this stuff is all in clear. So everything is working as expected. Now, of course, this policy is a really simplified version of what you can do on the FTD. This is not something that you would actually use in production. A real world example is going to be when you will start with the don't decrypt action in the policy, which is going to be used to make an exception for outbound traffic that you don't want to decrypt. Okay, next you would say that you want to decrypt all communication to your servers, or just some of those servers, the ones that are more critical to your organization. Then you would add another set of exceptions for outbound communication, but this time it would be specifically for traffic that is subject to legal regulations, like for example AJPAA, or maybe PCI DSS communication. Next, you would perform decryption on all outgoing web communication, of course, assuming that you want to do the decryption on the HTTPS connections, on all of them. And finally, the default action, you will leave it as do not decrypt, pass without decryption.